Hi, I'm Kashyap, and in this video we're going to learn and visualize binary search. So what is binary search? Well, it's a searching algorithm that's pretty popular and it's quite easy to understand. And here's how it works. So let's say we have an array of integers. Let's say the integers are 1, 2, 3, 4, and 5. So it's all the numbers, all the positive numbers, up to 5, starting from 1. And let's say I wanted to find out where the element 4 was. So here's how binary search would work. First, it would find the middle element or the middle value. So that means that it would do this divided by, the average of all these ones, and that would be your middle value. So the middle value at this point is 3. So what binary search does is our target is 4. Our target is 4. 4. So our target at the moment is 4. So what binary search does is that it takes the middle element and compares it with our target. So we know that our target is greater than our middle element. So what binary search does is that it takes the second half of this. So it takes the upper half. It's going to take 4 and 5. Now it's going to find out the middle value over here, which is 4.5. So over here, the middle value is just 4.5 because it's 4 plus 5, which is 9, divided by 2 is 4.5. Now it's going to compare 4.5 with 4. And since 4 is less than 4.5, this is our whole array or target array. And since there's only one element in this target array, this is our element. And we can find out that this element is at position 3 because using zero indexing, we can find that out pretty easily because 0, 1, 2, and 3. If you don't know what zero indexing is, I'll post a video about it soon. But essentially what binary search does is that it finds the middle element. I'm going to type it over here. Finds the middle element, right? Compares the target with the middle, right? And essentially what the code is doing is that it just cuts down our target array or our final searching field into half every single time we're doing this operation. So every single time we're finding out our middle value, we're cutting this operation, we're cutting this search field into half because we're either looking into the bottom half of the code, the bottom half of the array, or the top half of the array. And that's really useful. So we're finding the middle element, we're comparing the target with the middle, we're getting either the upper half or lower half of our search field. And we're going to repeat this process until there's only one element left. Until there's only one element left. So this is essentially how binary search works, right? It just finds the middle element. In our case, the middle element over here was 3. Right? This was our middle element. This is our middle element. And now it compares a target, in which case our target is 4. It compares it with 3. So we're going to compare 3 and 4. We'll do it right here. So 4 is greater than 3, right? 4 is greater than 3. And since 4 is greater than 3, we know that it's in the upper half of this search field. So then we only consider this. Now, our new search field is just 4, 5. This is our new search field. And we're going to do the average of this. So we're going to set this to A, and then we do the average of A. Average is equal to 4.5. That's the middle element. So now our middle element would be right down the middle over here. Just be right down the middle. And since we know our average of these two, or that's our middle element, we can compare 4.5 with 4. And since 4.5 is greater than 4, we know that 4 is in the bottom half of this search field. And now we've narrowed it down to only one element. And now because of that, we know where this element is. Now, in the actual implementation, we don't like actually separate them and cut them over here and bring them apart. We do it in the same array. We do it in the same array so we know where this element is relative to this array. Finally, where is binary search to use? There's one caveat to using binary search, and it's that the array must be in ascending order, right? Because you see over here, the reason that is because when we're trying to figure out the middle element and the upper bound and the lower bound of our code, or the upper bound and lower bound of our search field, we need to know the correct order of these numbers. And for that, we need to know the array in ascending order. So this is the only caveat when it comes to binary search, is that it needs to be in ascending order. In the next video for binary search, we'll go over how to actually implement it in Python 3. That's it for today, and I'll see you in the next one.